Okay, so the last couple of blocks in Agile Mind, we have been talking about ratios and rates and unit rates and proportions and constant proportionality. Now, we're going to take all of that information because we need to do all that so we can do what we're going to do now, and that is dealing with patterns in proportional relationships. So we are on block one in your book on page 63. And in the OneNote, it's page 1 of 4, and that should be in your class notebook. Now, everybody knows that blue and yellow can be used to make green. Well, I hope everybody knew that. If you didn't, you do now. Now, you'll notice that this table that we see here, we've got cups of blue paint, cups of yellow paint, and the ratio of blue to yellow. And so let's add a few things to this just to make it a little easier to understand. So the cups of blue paint we are going to use as our input in this case, okay? Because it says the mixtures of blue paint and yellow paint shown in this table create a particular shade of green paint. And we're going to list 5 other combinations of blue and yellow paint that will create the same shade of green paint. Well, we're going to use the amount of blue paint as our input, the amount of yellow paint as our output or our dependent variable. So we have our independent variable in our x, dependent variable is our y, and then we have the ratio of blue to yellow. So that would be x to y. Now, of course, you know that another way to write a ratio would be, to do the x over the y. But remember, there are 2 different ways to write a ratio. And because of what we've learned so far moving into this, we know that if we want to find the unit rate or the rate of change or the constant of proportionality, we always have to write it as y divided by x equals, some constant number. And that number had better be the same every time that we divide y by x. Because if it's not, then we don't have a proportional relationship. And like in this case, the color of blue to yellow will definitely not work out. So let's move our way down through this table. Now it says here, if we have 1 cup of blue paint, that would require 2 cups of yellow paint, giving us a ratio of 1 to 2. Okay, that makes sense. X is 1, Y is 2, a ratio of 1 to 2. All right. And then we have the next one, we have 2 cups of blue paint. There are 4 cups of yellow paint that we would need, and giving us a ratio of 2 to 4. Now, if we use 3 cups of blue paint, how much yellow paint would we need? Well, I would say that in this case, we would need 6 cups of yellow paint. And that would give us a ratio of 3 to 6. Okay. Thank you for that response in the chat. Yeah. And if I have 4 cups of yellow paint, of blue paint, 4 cups of blue paint, how much yellow paint would I need? I think we can all agree that it would be 8, just like somebody typed into the chat. Yes, absolutely. Giving us a ratio of 4 to 8. Okay. And, we can make our way down here. I think we figured out the pattern that we've got going on. 5 cups of blue, we would need 10 cups of yellow to make that same shade of green paint, giving us a ratio of 5 to 10. I hope it's easier for you to write in your book than it is for me to write on the screen. 6 cups of blue, we would need 12 cups of yellow, giving us a ratio of 6 to 12. And if we had 7 cups of blue paint, we would need 14 cups of yellow paint, giving us a ratio of 7 to 14. Okay. There, we filled out our table. That's very nice. So we have our X, we have our Y. All right. Now, if we look at our graph here in part B, something I also want you to notice before we move on is that when we're looking at the ratio of blue to yellow, all these numbers in here, these could also be considered ordered pairs. You know how we write ordered pairs in XY combinations? X comma Y, right? The X would be the one number and Y would be the other. That's an ordered pair that we would put into a coordinate grid, which you can see as we go down to our graph down here. They've done that for us a couple of times already. Now let me go here. I'm going to change my color on this. I go, yeah, there we go. Yes. Okay. Now, 1 cup of blue, right? 2 cups of yellow, 2 cups of blue, 4 cups of yellow, 3 cups of blue, 6 cups of yellow, 4 and 8, right? 5 and 10, 6 and 12, 7 and 14, and so on, right? Now, it would be really easy to take and connect these dots on our graph with a line. Right through those to the end of our graph. Let's see if I can those up. Boom. There we go. Look at that. Well, that's just beautiful. So now here's the thing, right? We have all these cool ordered pairs. We had 1, 2, 2, 4, 3, 6, 4, 8, 5, 10, 6, 12, and 7, 14. All these ordered pairs. And I also want you to notice that this line that we have here, or our graph, passes quite nicely right through the origin of our graph. So when we're looking at this graph here, we can tell, and you need it. Let's write this question down, okay? It says plot your ratios in the coordinate plane. What patterns do you see? Well, let's not worry about that at this point. Let's answer this question. Oh man, you know what? I'm going to type this question because it's going to be easier to do so. There we go. How can I tell in a graph that there is a proportional relationship? Man, you hear that feverish typing? Typing so fast. Okay, so how could you tell from a graph that there's a proportional relationship? Okay, that's a really important question to ask. Make sure you write that question down in your book. How can you tell from a graph that there is a proportional relationship? Okay, so point number one from this, the number one thing you want to look for, and we've talked about this, remember, first of all, for it to be a proportional relationship, it has to be a straight line. Like the one we see here, it is a nice straight line. And number two, that straight line passes through the origin. Now, if you remember what the origin is on a graph, it is at 0, 0. And you can see from our graph here that it definitely does. 0, 0, right there, passes through, and it's a straight line. So we know that the relationship between the number of cups of blue paint and the number of cups of yellow paint is a proportional relationship. Now, we can find the constant of proportionality. What is the constant of proportionality? Remember how we find the constant of proportionality. We divide y by x to find our constant of proportionality. And so every one of these, if we take our y value, like maybe this one right here, we take 4, we divide it by 2, and 4 divided by 2 is 2. So our constant of proportionality in this case is 2. So y divided by x equals 2. Also, y would be equal to 2 times x. So no matter what color blue or how many cups of blue we use here, we multiply that number by 2 to find out what color of yellow that we have. Okay, because remember x represents blue. Okay, so our constant of proportionality is 2. And remember, we always find that by dividing our y value by our x value, the input divided by the output. Nope, sorry, I got that backwards. The output divided by the input. Sorry about that, you got me. Output divided by input, or y divided by x, will always give you the constant of proportionality. Okay, so in order for it to be proportional on a graph, everything has to pass through a straight line through the origin. And on this table, how do we know if we have a proportional relationship? Because remember, well, where did my pen go? There it is. Every time that you divide y by x, you will always get that same constant number for your constant of proportionality. It has to be the same every time. Every time. That's how you know if you have a proportional relationship from a table. And from a graph, it's a straight line that passes through the origin. All right? Cool beans. All right, well, let's go to the next questions down here. Consider some of the proportional relationships that we explored earlier. Okay? As the change in gallons increases, okay, so let's take a look at this. As the number of gallons used increases, how does the number of miles traveled change? Well, okay. Well, let's first of all, let's take a look at this. Our first question here for 2A. Here we've traveled 296 miles and used how many gallons of gas? 1, 2, 3, 4, 5, 6, 7, 8. 8 gallons of gas. So we can use that information to find out the miles per gallon. Remember how we did that? We've done this before, but now it's still that same thing where the amount of gallons that you can travel, the amount of miles you can travel on a gallon of gas is a proportional relationship. And we can discover that by saying, all right, we want to know the miles per gallon. Remember what per is? That's that fraction bar, miles over gallons, miles per gallon. And we went 296 miles on 8 gallons of gas. And 296 divided by 8 is 37. So 37 miles per gallon, that's our unit rate. But that 37, that is our constant of proportionality. 37 miles for every gallon of gas. Okay, constant of proportionality. So if we were going to write this out, the number of miles that you can travel is equal to 37 multiplied by the number of gallons that you put in to your tank. See, and there's our equation. See, it uses that constant of proportionality. Now, if we look on our map here, I don't know if you probably can't see it super well. If we look on our map here, the relationship between the number of inches on the map and the number of actual miles, well, you can see the map scale. It says that 1 inch is equal to 5 miles, right? So there are 5 miles for every 1 inch. So how many inches are on this map? We can count them. There's 1, 2, 3, 4, 5, 6, 7, 8. There are 8 inches. So if there are 8 inches, how many miles is that? Well, you go from 1 inch to 8 inches by multiplying by 8. So how many miles is that in actual miles on the ground? Well, that would be 40 miles. So you can use a map scale to find out exactly how many miles you're going to travel, because that map scale will tell you, well, hey, for every inch, this is how many miles there are. Okay. And if we look at the last question here, in the original photograph, what is the relationship between the length and the width? Okay, the length and the width in this photograph. So we want to find that proportional relationship between the length and the width. Length to width. Well, the length was 6 inches. The width was 4 inches, right? Now, if we wanted to enlarge or reduce that photo and not have it be distorted, we need to find the constant of proportionality. What is 6 divided by 4? Well, it's 1.5. So 1.5 is our constant of proportionality. So if we wanted to find the length, we would have to multiply 1.5 by the width. So, and that's where we use the constant of proportionality in this case to write our equation. So you can always find the constant of proportionality in an equation because that's the number that's being multiplied by your input to find the output. All of this is pretty simple stuff. Okay. All right, we have just a few minutes left. In a certain town, there are 2 houses for every 5 apartment units, and we can use this information to complete this activity. So, like it says, there are 2 houses for every 5 apartment units. Okay, so if there are 2 houses, there will be 5 apartment units. And what is the ratio of houses to apartment units? Well, that's houses to apartment units. Or it can be written like this, 2 to 5, whatever. But what if there are 10 apartment units? How many houses would there be? That's an excellent question, wouldn't you say? How can we find that out? Well, let's see. And it appears that might be a question that would have to wait until tomorrow because we don't have enough time to finish this lesson today. So we will continue the lesson in the next video and in the next class section.